Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So welcome back to another weekend, my fellow assassins. I hope you all had a good week and are looking forward to enjoying the weekend. And I'm glad that we get a little bit of time here to spend with each other. And a quick update in regards to the show here. Fun fact, we are now available on iHeartRadio. So how about that? Now, I know that probably doesn't mean a whole lot to you guys because obviously if you're listening to this right now, chances are you're listening to it on some other app. But hey, if you're on iHeartRadio right now and you just discovered us, welcome aboard. Welcome to being one of the fellow assassins. We're glad to have you here. So I guess what we can do is we can start this episode off with our trivia question. So this week's trivia question should probably be a little easier for some of the, I wouldn't say the older crowd, but the people that have been using computers for a while. And that is because this week's question is, what is the maximum amount of RAM that a 32-bit system can have? What is the maximum amount of RAM that a 32-bit system can have? So that is your trivia question for the week. And in regards to questions, I'm not sure about you guys, but do you ever I don't know, you'll just be sitting or walking around, or you'll just have a random question pop into your head that literally no one has asked? Well, I had one of those this week. So I guess this isn't a typical section, but just for the heck of it, in this section of questions that literally nobody asked, I thought it would be kind of funny to ask the question of, if you had to describe podcasting in the most suspicious way possible that might lead people to think that you're a psychopath, how would you do it? Which obviously nobody asked this question, but I have an answer for you anyway. So how I would go about answering this is I would say, well, for about an hour each week, I lock myself in my closet and then record myself talking to myself. And then I spend another about half hour or so editing the recording of myself talking to myself, adding effects and music, before then posting it on the internet for everyone to listen to. Now, you're probably thinking a couple things. One, that does sound like something that an absolute psychopath would do, record themselves talking to themselves by locking themselves in the closet. But at the same time, you're probably also thinking, dang, that's pretty accurate to what podcasting actually is. And you are correct, because that is what I'm doing right now. Now, granted, other podcasters and probably more established podcasters would have something else to say. They'd say, I go to my recording studio. But I mean, heck, if you say you're going to a recording studio, first off, that's not suspicious at all. Plus, my closet is my recording studio, so there's that aspect. Now, and for what it's worth, I don't know about you guys, and I'm obviously not an audiophile, but to me, I think the audio quality of this podcast is pretty decent. Especially considering the fact that the microphone that I'm using right now is a 50 or under 50, I don't remember, something like that. It's not very expensive when it comes to microphones, and it's a USB mic that I got off Amazon. Now, a lot of the quote-unquote real podcasters and real content creators are out here using their hundreds of dollars worth of microphones and having their fancy sound insulation, and their microphones are these radio mics or studios, something I don't even know, cost hundreds of dollars, and then you connect them with with XLR cables to a DAC, which is a digital to analog converter, and then you plug that into your computer. But no, I am cheap in the sense that I just found a relatively inexpensive mic off Amazon and add a few audio effects, which, by the way, anyone that does any kind of like audio production, no matter how good their microphone is, they're going to be adding audio effects to it afterwards anyway. So, there's that aspect also. Now, I'm obviously, like I mentioned, I'm no audiophile, so you guys can correct me if I'm wrong. But personally, I don't think any of that extra stuff is really all that necessary, especially when you consider, like I mentioned, the fact that you're going to be adding audio effects to the end anyway. Besides, how can I afford all that high-end audio equipment when I have a home lab to fund? Now, this actually might come as a shock to some of you, but actually, now that I'm thinking about it, I honestly couldn't tell you the last time that I actually bought something for my home lab. Like, it's actually been a few months. Like, and I'm actually being serious about that. Like, it's been a while since I actually got anything for my home lab, which honestly, I might be going through some withdrawal symptoms, to be honest, not having bought anything for my home lab recently. Now, I will say, though, on the other hand, my bank account is very, very happy with me at the moment because I have not bought anything. So that tangent aside, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, it kind of stems from a podcast that I listened to this week, which, funny enough, was actually recorded like a while ago, like, I don't know, back in like end of the summer, early fall time frame. Like it wasn't exactly a recent podcast, but the basic idea for this week's cybersecurity tip is whenever you're backing up your data, especially if you're using any kind of cloud services, whether that's Dropbox, OneDrive, Google Drive, iCloud, whatever solution you're using to back up your data, if you want to ensure that whatever cloud provider you're using isn't snooping on you and looking at what you have backed up, make sure you encrypt your data before you put it in the cloud. Because it doesn't matter if the cloud provider says they encrypt your data. One, you can't exactly prove it. And two, even if they do encrypt your data, that's not to say they have keys stored somewhere that they can go in whenever they want and decrypt your data to look at your data. So if you're ever using cloud services as a means of backing up your data, which you definitely should have some kind of backup solution, as we've talked about before on the podcast. If you're using the cloud for that, I would highly recommend that you encrypt your data going into the cloud so the cloud provider can't snoop on you. And this probably doesn't come as a shock to anyone, but in case you needed any more reasons to hate Google, there have been multiple instances with Google, and I'm sure others as well, of Google snooping on people's photos, flagging them, locking them out of their accounts, and shipping their data off. So the instance that I heard about and that I'm bringing up here was an instance where a dad had pictures of his toddler that his wife sent him, since I guess his toddler had some kind of like rash or something, and as part of the whole like telemedicine type thing, they took pictures of their son's, private parts essentially to send to the doctor so the doctor could look at it. And unbeknownst to the father, those photos got automatically uploaded to, I think, his Google Photos, I think is what it was. And then Google was, combing through his photos, found those photos, and essentially flagged them as child porn and completely locked him out of his account, shipped off all of his data to the authorities, and completely cut him off from search, email, text, photos, everything. And they sent all of his data to law enforcement. So they sent his entire search history, all of his emails, all of his text messages, all of his photos, all of his location data, all of it. All the while shutting down his Google Fi mobile service, so law enforcement couldn't even call or text him to contact him. So they basically made his life terrible because they believed that he had bad stuff in his Google Photos. Now, the thing that's interesting about this is Apple got some flack, I think it was a year ago or so, for their CSAM detection, which, and I'm pretty sure Google does this too, and the point is to use artificial intelligence and machine learning to detect known images of child trafficking and pornography and that kind of stuff, to be able to flag it and take it down. But these were completely new images that weren't a part of any of those data sets, which is also kind of spooky. So obviously Google was doing some looking through of his stuff. Now, the thing that is also interesting is law enforcement then, found that there was nothing, that this guy was, completely, was clear. They cleared him. He obviously wasn't in the wrong at all because he wasn't. And Google still was standing by their decision to lock this guy out of his account, even though he was cleared by law enforcement, and they kind of refused to give his account back, which another thing that kind of also came up because of this, because he was completely locked out of his Google account, when I think he was also trying to do get a mortgage or something at the time. And because he was locked out of his Google account, he had to go have them try to send it to another email account, which kind of flagged the financial institution that he might be trying to scam them or something, which caused another mess in its own right. So yeah, and this isn't the first instance that Google has flagged people's personal photos of their kids like this. So I'll have a link down in the show notes to the article that I was referring to. So all this to say, cloud backups are definitely a great way to make sure that your data is safe, but it's also a great way to give companies tons of info, more than they could ever dream of, into your personal lives. So if you are planning or use cloud backup services to back up your photos, videos, music, documents, whatever you back up, make sure that if you don't want the cloud provider knowing what you have on there, make sure that you encrypt all your data before you send it. An easy way that you can kind of do this is you could have a routine schedule of backing. Say you I don't know how often you want to back or feel like you need to back up stuff, but say you do a monthly backup thing. Every month you back up your stuff, and then you take an archive, that kind of what I, that the NAS project that I talked about, archiving the NAS and copying it over to my Xserve. You basically do something like that, essentially, where you create an archive, a single tar or zip file or something of all your backup data, and then you encrypt that, and then you upload it to the cloud so you have a backup that way. That would be my recommendation. Or if that's too much work, you could always just do more incremental backups, if you want to back up your photos. At one point, you can just encrypt all of them and then send it, or however you want to do it, but encrypt your data if you're putting anything in the cloud. That way you don't have to worry about cloud providers snooping on you, locking you out of your account, or accounts, plural, and then shipping all that data off to law enforcement. So that is your cybersecurity tip for the week. So before we get into the nerdy things that I did this week, I want to give a little story that I think is kind of funny, kind of sort of related, but a little different. So I had quite the funny interaction with Siri this week. So I decided to ask Siri how many steps I had today. And Siri responded with, "I can't help you with that," which I found rather interesting. I found rather odd. I was like, why can't Siri help me with this? So I asked Siri, why not? And Siri's response was, "I don't know." Yeah. I asked Siri, how many steps do I have? And she said she couldn't tell me. Then I asked why not, and she said, "I don't know." Like, wow. And then I followed up with, if you're a virtual assistant and can look through my apps and my data, why can't you tell me how many steps I have today? And her response was, "I don't know what that means. If you would like, I can search the web for," and then repeats my question to me. Which, I mean, that's hilarious. Like, everyone's talking about, like, AI and machine learning and artificial intelligence, and Siri's over here not even able to tell me how many steps I have today, and gets confused when I try to press the question on why she can't tell me. So, artificial intelligence, ladies and gentlemen, let's give a round of applause. Also, for funsies, I asked if she was smarter than ChatGPT, and she says, "I don't have an answer for that." Which, I mean, I think we all know what the answer to that question is. But the thing that, I find kind of odd about this entire situation was the fact that she said she can't help me at my question about how many steps I have, which, I mean, it shouldn't be that hard because the Health app is literally built into iOS. It's a stock app. Like, she should have access to that. Now, I could understand if she wasn't able to give me that information because maybe that's like private or personal information and it's encrypted and she doesn't have access to it. If that was the case, I could understand that. But the fact that, when I pressed, why can't you help me with that? She just says, "I don't know." Like, I feel like there should have been some, like, more concrete, more, substantive response than "I don't know." Like, if in this, let's say the hypothetical case where it's personal information and it's encrypted and she can't access it because of that. She could have at least said, "I can't help you with that." And then I asked, "Why not?" And she said, "Because that's personal information and it's encrypted for privacy reasons," or something like that. That would have been like a legit response where, I mean, I could disagree that you still should be able to answer that question for me, but I can at least respect the fact that you gave me an answer as to why you can't help me rather than just saying, "I don't know." So, yeah. Artificial intelligence and machine learning algorithms that create, these AIs might eventually someday become robots and take over the world. But that day obviously is not today or anytime soon. At least it will not be Siri. That is for sure. So now, with that out of the way, let's get into what nerdy stuff have I been up to this week. So, as I'm sure you guys know, regular listeners of the show will definitely know that I love me some C and C++. But gosh dang it if it does not get on my last nerve sometimes, because this week I was on the verge of chucking my computer out the gosh darn window. Because to give you a little bit of insight into what happened with my C programming this week, this was basically a summary of how things went. Segfault, segfault, segfault. It works. All right, let me try it on a different operating system. Segfault. Okay, let me try this. Segfault. Let me try that. Okay, cool, it works. All right, let me try it back on the operating system I was originally working on. Segfault. So yeah, that was essentially my week. So basically what I was trying to work on was, back in undergrad, one of our projects was essentially to kind of simulate a CPU and memory and how it all works together. So we essentially kind of wrote our own assembly language, except it was super stripped down. There wasn't a whole lot to it. And it was kind of based off the ARM assembly language. But my biggest gripe with it was the fact that in order to write programs for it, you had to write everything in hex, which is not readable at all, one for one. And two, like, it's so hard to keep things straight, and you essentially have to have numbers memorized of, what the instructions are, and it's a mess. Now, people gripe and hate on assembly for being unreadable, but when you compare assembly to, reading straight hex numbers, I won't say it's like Python to assembly, but it's probably like, maybe a C to assembly, because it's pretty darn readable when compared to hex. Now, if it was binary, then like assembly looks like Python compared to binary. But yeah, so my thought was, what if I wrote a compiler that can allow me to write the assembly code that would then be translated down to the hex instructions automatically for me? So that's what I decided to try and do. Now, if you don't regularly check my GitHub, you probably won't know this, but I did push some of those updates to my GitHub, so you can now actually write programs in its assembly, in the CPU's assembly language, and it'll compile them and actually run them. Now, like I mentioned, the instruction set is very limited, and the compiler is still pretty darn buggy, but it does work. I have two example programs that I wrote on there in its assembly language. One is just a super basic Hello World program, which was quite the task to get to work with this compiler, let me tell you, all the debugging that was involved, and like I mentioned, all the seg faults that happened from it working, and then trying it on a different operating system and it crashing, and then fixing it, and then it crashing on the original operating system. And it was kind of, at one point, I think, kind of held together with chewing gum and duct tape, essentially. It's a little bit more cleaned up now, but it's still not foolproof and is still prone to doing some funkiness from time to time. And there are some places that I haven't completely ironed out. So it's definitely very much a work in progress, but I thought it was a fun project. And I will say it has definitely helped me better understand like assembly, because, trying to figure out how these assembly instructions work and how to convert them and how, basically translate them has definitely helped me better understand assembly. But if you're also wondering what happened to that other compiler you talked about like 2 weeks ago that was a distributed compiler? And yes, that is a different project, and I am sorry to say that I have neglected that project because, like all computer scientists and programmers, I have too many project ideas and not enough time to work on all of them. So I got sucked into this project this week, and I have essentially neglected that project. And I kind of feel bad because that's a really cool project, and I want to make sure that it works on other operating systems, or at least try to, besides just Linux. But, you know, I only have so much time in a given week to work on personal projects. So there's that. Also, this is another side note, not something I did this week. But remember last week when we were talking about the new Macs that dropped, and I said that my Mac Pro wasn't supported yet and still only, or at least isn't supported yet on OpenCore, and I still have to run Monterey on it? So that information's outdated already. So literally before I came to record this podcast, I found that OpenCore just dropped a new update, 6.0.6.1, which now adds support to both my Mac Pro and my Xserve. So literally less than 24 hours ago, at least as of the recording of this podcast, is when they dropped that update. So probably at least part of the stuff I'll be talking about in this Nerdy Things segment for next week will be how that upgrade process went, since I'm planning on trying to upgrade those now that they're officially supported by OpenCore, and hopefully things will go smoother than they did last time. Since my Mac Mini I mentioned, that was another one of the computers that I tried to upgrade before Christmas that essentially went horribly wrong, and I had to completely wipe it. And that has been rock solid since I went through the process of reinstalling Ventura on there. So hopefully same holds true for when I do it on the Mac Pro and on the Xserve. Now, the last thing that I want to talk about, which also kind of ties into the main topic of this week's episode, is I built my very first Docker image from scratch, which I am super happy about and super proud about. I've wanted to kind of get into Docker and really get into it and kind of, work with it. I mean, I've deployed Docker containers before, but that's generally just like using a Docker Compose that I either found or maybe kind of took a Docker run command and converted it to a Docker Compose. But I didn't really, and I think there was like once or twice that I did, build a Docker container and Docker image from scratch, but it was mainly using someone else's Docker file, and I may have tweaked like one or two things, but that was it. But this time I wrote the application myself, and I wrote the Docker file myself, built the image myself, and deployed it. And man, was it so cool. So the container that I wrote, was for so I have on my GitHub a multi-threaded server that I wrote in C, which is just a super basic multi-threaded implementation of a server. Basically, it accepts queries for files and it will send the file back. So obviously not a very secure server in the sense that if you knew the file paths, you could get some files that you really shouldn't get access to. But just as kind of a proof of concept, is kind of a cool project. So I decided, hey, this is a server. So what if I create it into a Docker container? That would be pretty cool. So I went through the process of building the container and putting the server in there and running it. And once you know it, it works. And I have to say, it was pretty cool. I thought it was really cool. So since I've gone through this process, I do have some tips for you guys if you're interested in getting into Docker and making your own Docker files and building your own containers. And The first is so when I built this container, what I did was, rather than building the executable first and then copying it into the container, what I did was I built everything natively in the container itself, so I wouldn't have to worry about any kind of funkiness going on with incompatibility, because as we have mentioned numerous times on this podcast, C does not always play nice across different operating systems. Now, granted, the container was Linux and the computer I'd be building it on was also Linux, so theoretically it should be fine. But as I noticed when I tried to build it in the container, it was not fine, and it did not compile, at least initially, whereas before on every other not Windows, because it doesn't work on Windows, but because the socket library is completely different on Windows. But the Linux computer server that I was running it on originally, it worked perfectly fine, had no issues compiling, but when I tried to compile it in the container, it was not happy. Now, granted, it was a different distribution of Linux. The distribution for my server was running was Ubuntu, and the distribution that I was building in the container was Alpine Linux. So there was that might have played a role. Probably also played a role with my assumption is the GCC compiler from the Alpine repo was slightly different than the GCC compiler on Ubuntu, and that's most likely where the issue came from. But anyway, I got that resolved, and I tested it, and it worked, and everything was great. But the thing that I wanted to bring up is, if you're building your own images and you are doing something like that, where you're building the code natively in the container, if you want to make sure that your container isn't bloated in this sense, one thing you have to do is you have to make sure that your instructions for the container to install the applications that you need to building it, and then removing those applications all have to be essentially in the same command, which definitely makes it one chunky boy when it comes to the command. You're going to have multiple lines of commands, a lot of ampersands in there. So that's one thing that you kind of have to watch out for, because I tried, having making it more readable and having, a command to install the packages, a command to build the application, and then a command to remove the no longer needed packages. And for whatever reason, my Docker image was still pretty darn big, and I couldn't figure out why. And then I was doing some digging online and found, so when you run all these commands, they're essentially running in different, I don't know what the right terminology is, but they're essentially running in their own segmented things or containers, something, I don't know. But basically, if you install the packages and don't remove them in that same exact step, they won't get removed, so they stay inside the container, which is kind of weird. So if you're looking to make a container of your own, make sure that you do all of your installing and any uninstalling of dependencies in the same command, in the same command line. So it'd be install XYZ and build program and remove packages, something like that, rather than doing command and then another command, whatever. So to give you a sense in how much this actually impacts things, before I properly removed the packages from my image, the application, the total size of the Docker container's image was around just over 250 megabytes, which granted is a heck of a lot smaller than a virtual machine, But when you compare that to what it was after I successfully removed the packages, which ended up being 9.7 megabytes, 9.7 megabytes is a heck of a lot smaller than 250. So make sure you remove your unneeded packages from your Docker images. So that's my first recommendation. The other recommendation I have is I mentioned I used Alpine Linux, and I would honestly recommend that you use Alpine just for the sake of how small it is, because the base Alpine Linux image is literally like 7 megabytes. So if you really want small Docker images, Alpine Linux is probably the way to go on that. Now, we've been talking about Docker containers, and I've mentioned Docker containers before, but I kind of wanted to take the remaining time in this episode to talk about going more in depth with Docker and DevOps as a whole, and kind of how they can be used together to improve software deployments and all that good stuff. So the Docker file, a lot of people are probably maybe a little confused if you've never experienced Docker before, which I can't really blame you, because it is kind of, an interesting concept. So basically what a Docker file is you can kind of think of it as an automated way to build your environment for your application to run in. So the first thing that you have to do when you're making a Docker file is you have to figure out what base image you want. And basically what this is kind of like the base. You can think of it like if you're making a virtual machine, what operating system you want to use. And that's essentially what your base image is. Now, the base images can range from anything from just a super vanilla image, like I mentioned Alpine. You can just have a base vanilla image of Alpine, or you could even go further and have take already made Docker containers. So you could literally take the Docker container that I made, which it's not on any kind of Docker Hub, so you'd have to build it yourself. But if you built it yourself, you could use that image that you just made as your base image for something else if you so chose to. So that's the first step. The next step is you have to set up your environment. So that is anything from copying any files or executables you need into the Docker container, and then maybe any kind of building of the container. So in my case, I had to install some building tools like GCC and Make and all that good stuff to be able to actually build my executable. And you build the executable, and then ideally any packages that you installed that you no longer need, you remove those to minimize the size of your image. And then after that, you can kind of, at least in my case, all I had to do after that was expose the port that I was using for this application, so it could actually work as a server, and then the command that's needed to start the server itself. So when the Docker image gets spun up, it can actually start your executable. So that's kind of a little bit on Docker files. So getting into more deep into Docker. So in a nutshell, it's a container, as we've mentioned. A Docker is a container which houses everything the application needs, so all the libraries and dependencies and all that good stuff that it needs to run. And it's similar to a virtual machine, but it's also slimmed way down. Because as we see, my Docker image, which has because it has and only has what it needs to run, it can be a heck of a lot smaller than if you installed a virtual machine and then put your application on a virtual machine. So a virtual machine, you're talking gigabytes. Docker images, you're talking megabytes. So we're talking orders of magnitude smaller. And because they're so much smaller, what this allows you to do is, because they're so much lighter weight than a virtual machine, you can run a lot more of them on the same system because they're not as taxing resource-wise as, a virtual machine is. Because in the case of a virtual machine, you have to support literally an entire operating system, an entire kernel, an entire, all the processes that go on to make an operating system function. Whereas in Docker, because you only have what's needed for the application itself, there's not as much stuff running in the background, you could say, in the container. So it's a lot more efficient in that way. The size of the containers are a lot smaller, so you can run more of them in essentially the same amount of resources. Because the other nice thing about this too is because everything's contained in this container, and in this case, Alpine Linux with my container that I made, because everything's contained in there that it needs, and it's on the operating system. I guess I could kind of put that in air quotes, because everything's contained in there. It's the cross-platform compatibility just kind of goes through the roof, because it's essentially, in a way, kind of like Java, in the sense that because Java runs in the Java virtual machine, it can run anywhere regardless of the operating system, and you don't have to run into the issues like you do with C, where your code can compile and work fine on one machine. It can compile on another machine but not work, or it could just straight up fail to compile on a different machine, and you don't really know what you're going to get. But with the nice thing with Docker, because everything's contained, you can literally any system that has Docker installed and can run Docker containers, it'll work just fine. It'll work perfectly, just like it would if you have Docker installed on Windows. The Docker container will work the same on Windows as it will on a server running Linux with Docker installed. It'll work the same across whatever system you run it on, which is one super nice thing about Docker also. And because it's so stripped down, you could kind of see this as an improvement to security too, where it's an improvement to security and also kind of a detriment to security at the same time. So it's an improvement to security in the sense that because it's so stripped down, if there's an underlying program in your operating system that has a vulnerability to it, because your container is so stripped down, the chances of whatever that underlying program is being inside your container is very reduced, because realistically that whatever service or whatever that is in the operating system isn't included in your container. So that's one thing. On the flip side though, because it's so stripped down, you don't have as much control over it in regards to like hardening the system. Whereas because if you have a virtual machine, you have an entire operating system and all the tools that come with that operating system, so you can really lock it down a lot more than you could, say, lock down a virtual machine. But in the same regard, because there's so little to the container, if someone somehow managed to hack into your container, again, because everything's in a container, they can't really do anything. So in that sense, it's also beneficial to security because it minimizes your overall attack surface, which is generally a good thing when you're trying to reduce your risk of security, any kind of like security, like getting hacked or ransomware or anything like that. You want to reduce your attack surface as much as possible. And generally the way you go about doing that is not having a bajillion services running on one server. Because if you have one server running, say a web server, an SQL server, an SSH server, and, any other kind of services all exposing those ports, that's just a ton of different entryways that someone could get into your system. Whereas if you segment all of those off onto different virtual machines, in one case, then that reduces the attack surface of a given machine. But then if you put those into containers, that could essentially reduce the overall attack surface even more, because everything's in an even smaller container rather than an entire operating system. So that's from the security aspect. So as we kind of touched on a little bit here, in regards to how are they similar and how they're different to virtual machines. Virtual machines, like we mentioned, is an entire operating system and has all of its resources and is a lot heavier weight and generally isn't as portable as Docker containers are, because Docker containers, you can literally just, there's this thing like, Docker pool, and you can literally pull down an entire Docker container, from like Docker Hub, for example, in a matter of minutes. Whereas you don't really hear that happening with virtual machines, because virtual machines are just so much, heavier and resource intensive. And the other thing is, whereas a virtual machine, everything from the hardware and resources and everything, that's included in the operating system that comes with it being a virtual machine, whereas Docker shares that stuff with the host machine. So because it only has what's needed for the application to run, it's able to share the host's, CPU and memory resources, so it doesn't have to do any kind of that managing on its own. So that's another benefit to it, and it allows it to be smaller. But since, like we mentioned, virtual machines, there's more to them that also gives you, more customizability to harden it or, do anything that you want to in that regard. But again, that comes at the cost of being resource intensive. So now we kind of talked about Docker. So now DevOps, usually Docker and DevOps are kind of go hand in hand. So the one thing that when people talk about DevOps that I think is generally kind of a misconception is the fact that DevOps is a certain tool or suite of tools, like DevOps is Jenkins, for example, because Jenkins is a tool that a lot of people in DevOps use, or it's Jira, or it's Confluence, or some other tool that is DevOps, which that's not the case. DevOps is just, put simply, DevOps is just a set of practices that allow dev teams, or just teams in general, to collaborate more effectively and deliver applications more quickly. And the way that it does this is tools, yes, but it does this through a combination of automation, CI/CD, or continuous integration and continuous delivery, and monitoring solutions, essentially to automate the boring stuff, I guess you could say, so to allow you to more focus on developing and coding and, making great applications. So because you have these automation tools in place, rather than going through the process of, committing your code and checking it into your Git repo, then having to go through the process of creating a build for it, testing the code, deploying the code, you can automate that entire process through the pipelines. Since in ye olden days, basically, so the way that DevOps gets its name was, back in the day, you had dev teams and you had ops teams, or operations teams. And these were essentially two different teams, and the dev team, as it sounds, were the developers. They would write the code, and then once they finished writing the code, they would throw it over the fence, if you will, to the operations team. And then the operations team would be tasked with, all the testing and the deploying and all that stuff. And then if something went wrong, they would throw it back over the fence to the dev team, for the dev team to fix any bugs or whatever. And then the dev team would throw it back over the fence to the ops team. And as you can see, this is, kind of a lot of back and forth. And because there's so much back and forth, communication is kind of a key here, but in reality, there generally wasn't as much communication as there should have been. So DevOps essentially is to combine these into one and automate the process so you don't have to worry about throwing the code back over the fence constantly. So now how does Docker play into this? So when you combine Docker with DevOps, it can create quite a beautiful thing, in my opinion. So because you can automate the process, as mentioned, so Docker is built with a Docker file, and a Docker container contains everything that your application needs to run. So, and because DevOps uses pipelines as one of their keys to the automation process and the building process, imagine this scenario, if you will. Imagine you check your code into your Git repo, and as soon as you do that, it sets off a chain reaction. So it sets off a CI/CD pipeline, which once you check your code in, it automatically runs your code through the automated test suite that you have. And then once it passes that, it uses the Docker file that's included in the repo to put your code and compile your code into a Docker container with all of its dependencies. And then you can even throw Kubernetes in the mix here. And you can have Kubernetes, once that Docker container is made, you have Kubernetes automatically deploy that Docker container throughout your entire infrastructure. And literally all you did as the developer was type git commit, not git, well, that was the first thing you did. And then once you did git commit, then you did git push, pushed it to the repo, and all of that happened without you lifting a finger. That is the power of DevOps and Docker. When you combine them together, you can essentially, so before you would have to do every single one of those steps manually, but now everything's can be done for you. And then and in the case where it fails in one of those processes, it can, send you a notification. Like, say, for example, you fail one of the test cases. It can alert you that X test case failed, and then you can see, okay, this test case failed. You can make the changes in your code, recommit it, and then it'll set off that entire process again. And then if everything goes smoothly, your application's deployed and you literally didn't have to do anything. So leave it to the software developers out there that were literally so lazy that they didn't feel like actually deploying their code. So they literally created an entire automated pipeline process to do it all for them because they're lazy. That is the innovation of software developers right there. That is a prime example of software developers being lazy and over-engineering a solution to make their lives easier to feed into their lazy habits. That's what I'm talking about. So, with that out of the way, let's get back to our trivia question. So, if you'll recall, this week's trivia question is, what is the maximum amount of RAM that a 32-bit system can have? So the answer for this, which actually you theoretically could have been able to calculate this if you if you did some exponent calculation, but the answer is 4 gigabytes. So if you said 4 gigabytes, congratulations, you got this week's trivia question correct. Now, I want to kind of go into why it's 4 gigabytes. So the limitation of why a 32-bit system can only have 4 gigabytes of RAM is because a 32-bit CPU can only access 32 binary numbers, so 32 bits, which comes out to 2 to the 32nd power, which comes out to, what is this? 4,294,967,296. So that many bytes, which then translates to 4 gigabytes. So anyone jumping ahead and doing the math at home, technically speaking, a 64-bit machine could theoretically have a maximum of around 16.8 million terabytes of RAM, which translates to about 16,384 petabytes, or about 16 exabytes of RAM. Now, you might be thinking that seems like a lot, considering that, an average computer nowadays probably has 16 gigs. So 16 exabytes is a little bit bigger than 16 gigs. But if you ask me, that's pretty weak, considering that that's only 0.00001845 yottabytes of RAM. Now, if you ask me, those are some pretty rookie numbers. You're having 4 zeros of yottabytes of RAM, which, come on, that's pretty weak. Those are some rookie numbers. You got to step it up. 64-bit CPUs. You got to get on the big boy levels. So yeah, that's going to do it for me this week in this episode. If you enjoyed this episode, I ask that you leave it a rating and review, and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member, especially if you know any software developers that might be interested in learning more about Docker and DevOps. And if you have any questions about this episode, or you have topic suggestions for future episodes, feel free to shoot me an email at contact@darkassassinsInc.com. Link for that is down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.